Have you ever encountered a situation where your programming tools just don't seem to handle the task at hand? It's frustrating, right? If you've been wondering why chrono time point isn't large enough to store struct timespec, you're in the right place. Today we're diving into this technical conundrum. I completely understand your concern. Many developers have faced similar issues when working with time representations in C++. You're definitely not alone in this struggle, and it's a common topic among programmers. Let's look at the specific question at hand. One user recently asked, why is chrono time point not large enough to store struct timespec? They pointed out that on a 64-bit Linux architecture, the time point and duration classes seem limited in their ability to handle maximum time ranges at high resolutions. Sound familiar? Let's explore this together. So what's going on here? The issue arises because chrono time point and duration classes use a single 64-bit integral type for storage. In contrast, struct timespec and timeval utilize two 64-bit integers, one for seconds and one for nanoseconds. This difference can lead to limitations when dealing with larger dates and time spans. And stick around. At the end of this video, I'll share some insights on potential improvements and what you can do to work around these limitations. To understand why chrono time point is not large enough, the user should first recognize that it uses a single 64-bit integer for storage. This limits the range of time it can represent. In contrast, the struct timespec and struct timeval use two 64-bit integers. One integer stores seconds, while the other stores nanoseconds, allowing for a much larger range of time. This design difference means that while chrono time point is suitable for short durations, it may not handle larger dates or wider time spans effectively, leading to potential issues. The user should also be aware that this limitation has been acknowledged in the community. There are ongoing discussions about improving the API to better handle these scenarios. For now, the user can consider using struct timespec or struct timeval for applications that require handling of larger time ranges and higher precision. Fun fact, the Y2K bug was a wake-up call for many developers. It taught us the importance of planning for the future, especially when it comes to time-related data. Now let's look at the answers provided by other users. One alternative approach is to use chrono nanoseconds, which is a type alias for chrono duration with a signed integer that has at least 64 bits of storage. This allows for a time range of at least 292 years with nanosecond precision. The user also points out that you can choose a wider type for your time representation if your implementation supports it. Additionally, you can create a namespace with type defs that mirror chrono ratios using your wider type. Here's a thought. Keep an eye on updates from the C++ Standards Committee. They are aware of these limitations and may introduce improvements in future versions. And there you have it. Understanding the limitations of chrono time point can help you make better decisions in your programming. If you found this video helpful, please subscribe for more insights and don't forget to share your thoughts in the comments.